Alright students, so in this part we are going to start with the next concept, and that is electromagnet. So here we are going to start with electromagnet. Now what basically is the electromagnet? As the name suggests, that it is a magnet which is formed with the help of the electricity. So this is an electromagnet and this is a temporary magnet. This is a temporary magnet. It will show the property of magnetism as long as the current is being passed. As the name suggests, it is an electromagnet. So as long as we are providing the electricity, it will retain its magnetism. So this is temporary magnet formed when an iron coil, iron core or iron rod is placed inside a solenoid. So it means this iron core will show the property of the magnet when it is placed inside a solenoid. What type of solenoid? It is very important. It is current carrying solenoid. As we have already said that it can pertain or it can show the property of magnetism as long as the electric current is being passed through something. And that something is here is solenoid. What a solenoid is, that we are going to discuss in a minute. But this iron core will become a temporary magnet when it is placed inside a current carrying solenoid. It means the solenoid which carries current. There is one more definition. It is a temporary magnet formed when a coil or a current carrying coil is wounded around an iron core or rod. So the definition is pretty much same in both cases. They denoted that it is a temporary magnet which is formed with the help of the iron core. In both the cases we are having the iron rod or iron core, and in both the cases we are having the current. Alright, the thing is, here we have used or we have make use of one specific word which is solenoid, and here we are saying it as a coil which is wounded around the iron core. Now this solenoid is also a coil. What type of coil is known as solenoid? That we are going to discuss now. Now all the coils are in this shape like this. These are the coils. This is also a coil. If it is of the lesser diameter, it is also a coil. A more bigger diameter, it is also a coil. Alright. So these three, all of them are coil, but there is a special property for a coil to be a solenoid. See, these are all the coils, but all of these, they are not the solenoid. There is one special property for a coil to work or to function as a solenoid, and that property is, for solenoid, let me write it here, for solenoid, the area of cross section should be extremely less than the length of the coil. So for the coil to be solenoid, its area of cross section should be extremely less than the length of the coil. So it means if I am making a coil like this, then it is simply a coil. But if I am making a coil with a very smaller diameter or very smaller area of cross section, but its length is very, very long. So this is the length of the coil. This is the area of cross section, or let us say this is the diameter of the coil, and pi d square by 4 will give the area. So we are writing it as diameter or as area. In this case, the area is very, very less than its length. So it means this is not now known as coil. This is known as solenoid. So solenoid is also a coil, but there is just simply a variation in the definition. Either we are writing it a coil or we are writing it a solenoid. But this definition is far more precise and accurate because the electromagnet is created with the help of this current carrying solenoid. Alright. So here we have noted the difference between a coil and a solenoid. A solenoid is a coil having the area extremely less than its length. Alright. So this was all about the solenoid and the definition of the electromagnet. Now we are going to start with the circuit diagram on how we can create the electromagnet. Alright, so now we are starting with the circuit diagram on how we can make an electromagnet. So we have discussed that for electromagnet we need a solenoid. We know that solenoid, the area of the cross section is very, very less than its length. But because of the understanding, we are magnifying the thing. Alright. So we are just making a coil with a wider area so that we can easily understand the working or the construction of that electromagnet or the circuit diagram. So this is that solenoid. This is the solenoid. Alright. Inside it, we have placed an iron core. So this is the iron rod like this. So this is the iron rod and this thing is the solenoid. Alright. So either the coil is wounded around the iron rod or this is a solenoid, iron core is inserted inside the solenoid. Both the definitions are true. Now this is connected to the external circuit. This thing is connected to the external circuit. Alright, what is the external circuit or what are the things that the external circuit is having? First is this battery. This is the DC supply which we are getting, a DC supply of a battery or a cell. Then we have made the connection with the ammeter in order to measure the current. Then we are having a rheostat or a variable resistance. We'll discuss its working later. And a key over here. This is the key. So let me just label them up. This is the ammeter. Ammeter helps in measuring the current. Alright. This thing is the rheostat. Rheostats help in changing the amount of current. And this is key. What type of key? This is plug key. Alright, this is a plug key and till this case it is open. So if the key is open, the circuit is incomplete and the current is not flowing right now. Alright, the thing is when the current will be going to pass, there will be the generation of the magnetism, and if the magnetism is generated, it means there will be the formation of the poles, that is the North Pole and the South Pole. Now in order to determine the poles, there is one rule. The rule is known as the clock rule. A very, very important rule which is known as the clock rule. The clock rule says if the current in the coil is in the clockwise direction, if the current is in the clockwise direction, then the pole over that side would be the south pole. If the direction of current is clockwise, then the pole over that side, that is the magnetic pole over that side, would be the south pole. And if the current is anti-clockwise, then the pole formed would be the north pole. Alright, so this is towards only one side. If towards one side the current is clockwise, the pole formed would be the south pole. If the current is flowing in the anti-clockwise direction, over that side the pole would be the north pole. This is what the clock rule says. Now let us just start the flow of current and then we'll see which pole, that is which side, will get which pole. So by closing this, now the key is closed and the current will be flowing. Now we know that current flow in this direction. From the battery it is moving over here and it is entering like this. It is entering from here, here and so on and so forth. It is moving like this and ultimately it will leave this thing over here. Alright. So this is how the flow of current is. Now we'll have to see the direction of the flow of current from one side. So let us see it from this side. We are visualizing it from this side. Now over this side, if we can clearly see, the wire is wounded in this direction. The wire is wounded in the clockwise direction. So the wire is in the clockwise direction. If the wire is in clockwise direction, it means the current is also flowing in the clockwise direction. So here the flow of current is in the clockwise direction. Alright, this is the flow of current. Now from my side, it is in the direction of the clockwise. So just I am turning this hand towards the side of the camera. Now you can clearly see that this direction is the clockwise direction. And if the direction is clockwise, it means that the pole formed would be the south pole. So over this side we are getting the south pole. So over this side we are getting the south pole. Now again we are considering this thing one more time. So this is again moving in the clockwise direction from my side, that is from the side of the camera. Now, if I want to note the opposite side, that is the side which is away from the camera, that is towards this side. Alright, now again I want to see the pole over the farther side, the other side. We know that if from my side this direction is clockwise, if this direction is clockwise, from the other side, from the other end, it would be anti-clockwise. So if from my side it is clockwise, so over this side we are having the south pole, and from the other side the same movement which is clockwise from my side will appear to be anti-clockwise over the other side. So over that the pole formed would be the north pole. So towards our side it would be the south pole, and toward the other side it would be the north pole, because here the current is in the clockwise direction, so south pole. Here the current is in the anti-clockwise direction, so north pole. So again, one more time, this movement is the clockwise from one side. Now the other person visualize it in the form of the anti-clockwise. Alright, one more time. If I am rotating it like this, from my side, if I am visualizing it from the side of the board, it is clockwise. But over the side of the camera or your side, it would be anti-clockwise. So it means that over the side of the board, the pole formed would be the south pole, and towards your side, it would be the north pole. And the same case is over here. So if clockwise, the south pole; if anti-clockwise, then north pole. Now, let us see what is the function of the rheostat. Now, by the formation of these two poles, this iron rod is now magnetized. This pole is now magnetized. If I want to increase the strength of this magnetism, if I want to make this a stronger magnet, what will I do? I will increase the amount of current, and that is being manifested, or that is being done by the help of the rheostat. This rheostat will help us increasing the amount of current. If the current is going to increase, the magnetism will be increasing. Again, if we want to reduce the magnetism, this rheostat will again help us to reduce the amount of current, and thus will help in reducing the magnetism. Alright, now imagine this current is now closed. The key is closed, the key is open. It means it has again is open. So the circuit is again open. If the circuit is open, no current will be going to flow. If there is no current, there is no direction as clockwise and anti-clockwise, these poles will not be generated, and there will be no magnetism. So that is why, as long as the current will flow, it will remain magnet. When the current stops, it will lose its magnetism. So that is why this electromagnet is temporary. So electromagnet is temporary. Alright. So there is one more thing, that how we can increase the magnetism. First is by increasing the amount of current. The second thing is by increasing the number of turns. If we are increasing the number of turns, then obviously the amount of current is going to increase, and that is why the strength of the magnetism will be increased. Alright. So the second thing is, first thing to increase magnetism is to increase the current, and the second thing is to increase the number of turns. Alright. So these are the two things by which we can increase the magnetism of this magnet. First is by increasing the amount of current, and second is by increasing the number of turns. Alright. So the clock rules helps us to find out the polarity, and this is the electromagnet, which is a temporary magnet. Alright, it will lose its magnetism as soon as the current is switched off. So that is why it is a temporary magnet. Alright. So this was all about the magnet, and here the magnet which is created is the bar magnet. Alright. Now we'll discuss how we can create a U-shaped electromagnet.